First off, I'm a millennial, and they say things don't happen if you don't take pictures. So it's late in the day. You mind just standing up? Yeah? Bring a little bit of energy. Act like you're having fun even though you haven't yet. One picture. Cool. Whoa. While you're standing, this is the beauty of being on stage, is I get to control when you sit back down. One of the challenges with doing a workshop with X number of people in a room is you don't know experience levels. It's really hard to build something that's tailored towards everybody in the room. So just kind of a quick show of hands. How many people have experience with streaming in React? Oh, we're gonna learn a ton today. Cool. Next step of that, which I imagine is even less than, is how many people have experience in PPR? Cool. All right. The beautiful thing when people don't raise their hand is that makes my job a lot easier, because I just have to know barely more than you do to pretend like I know a lot, or at least you think I do. So what we're gonna do, there's a QR code on the screen. If you formally registered for this, you should have got an email for a GitHub repository, which is what this QR code goes to. In this GitHub repository, if you're following along hands-on, the expectation is that you have the repository downloaded locally, you have packages installed, you run npm run dev to have this running locally. And what we're gonna do is kind of iterate on an idea that I'll explain in a second to kind of build out a not so hypothetical scenario that we will walk through. If you don't already have the GitHub repository downloaded, I don't know if you have any challenges, Wi-Fi or not. If you look inside of the README though, you will see that there are, I would say, fairly detailed instructions. It's basically a long blog post that kind of gives context for what we're doing and why, as well as code snippets that we're gonna copy and paste in. And then if you're doing this on your machine, you'll be able to see the impact of that. I will also be showing all of that up on the screen as well. So you have the ability to do this hands-on, copy and paste yourself. You can also kind of sit back and watch what I'm doing up here, whatever works for you. That sound good? Oh yeah, you can sit. Thanks for the reminder. It's funny, half the room had decided they were gonna go ahead and sit regardless, which I highly respect. So, my name is James Q. Quick. I run the developer experience team at a company called BigCommerce. We've got a booth right around the corner. The big CTA was to tell you to come talk to us at the booth. There's 30 minutes left in the conference after this, so find us at the happy hour, I guess. But one of the interesting things is when I started last September, I specifically started working for a company called MakeSwift. They're a visual website builder that integrates with Next.js, who had already been acquired by BigCommerce. And one of the things that they were building was this UI library called Vibes. There's a couple of links in here to things that I'm talking about, including Vibes, that you can go check out. And the interesting thing with Vibes, it's kind of a copy and paste UI component library, something similar to ShadCN. How many people have seen or heard or used ShadCN? Probably a lot of hands. The thing we wanted to do differently though is go ahead and take care of all the things that you would need to do in a Next.js world with your components. The biggest aspect of that is handling modern Next.js/React features by being able to use React Suspense, doing data streaming, showing loading skeletons, etc., to make the developer experience as easy as possible as you copy and paste these components into your own code. So what I want to walk you through is part of the learning journey that our engineering team went through and actually building that out, and some of the things that we've learned to support all those features and what we consider our best practices, and talk about PPR along the way. So we'll spend most of our time in the actual code. I'll zoom in now that we're kind of past the initial QR code. How are we doing size-wise? Maybe another one for the back? Is that reasonable in the back? Yeah, I got one thumbs up. That's enough for me. How about code here? Is that one good enough? One more up? All right. It's always a challenge doing live demos like this. So if we were to look, let's go ahead and look inside of the source code. We have two files that we're really going to care about, and these represent the two different aspects of, one, the kind of library that we're building, or the component within this library that we're building, and then the person that's using that component. So inside of our page.tsx file, this is just the root page component, we are referencing this product list component. And in this case, we're passing it a static list of default products. This is all just kind of dummy data down here that we just passed to that component, and this component probably does what you expect, which is just to render a list of products. So you can think of the page.tsx as the consumer of this component library, and you can think of the index.tsx inside of the product list component folder as the actual UI component library itself. So we're going to build out functionality and features into that component, and we're going to consume that inside of the page.tsx file. Inside of here, there's lots of stuff. There's lots of code that's built in. Styling's already taken care of for you. There's interfaces for props. And we're going to go through and just kind of iterate on what this looks like. So let's go over to not my Gmail. We definitely close all tabs other than demo before we get on stage, as if we've done this before. There we go. So refresh the page. You won't see a whole lot there, although it's loading more than I would expect it to. But we're passing in static data to this component. So we have the static list of products, and we can start to think about doing streaming of data. So basically what we have now is we go to the server responds back with some markup, it renders in the page. But what if we were to change this a little bit to say, hey, we want to take advantage of React server components and being able to load data on the server within a React component. How many people are familiar with React server components? Probably seen the memes of like database calls directly inside of your React component. So we'll do something a little similar to that. If I can scroll down to the right snippet, we'll just kind of fake making a network request. So basically what I'm doing here is just wrapping a promise around the default products array, that static array. We set a timeout for 2,000 milliseconds, so 2-second delay. We await that. To be able to use await inside of here, we have to mark our function as async. Now we have this list of products. We can now pass this list of products to this component. So we have our default list. It's just a static list, a static array. We now are wrapping that in a promise that includes a 2-second delay to simulate some sort of network request, and then we pass it into our products list component. Any guesses at what the experience is going to look like in the browser now? What was that? It'll just wait. It'll just wait? Yeah. So let's see. We'll do a refresh in here. This is going to be hard for you to see. It's actually very hard. At the very top of Arc, there's a little loading indicator that shows that it is in fact loading for about 2 seconds. So what does this mean? This means that we send a request to the server. We use await. It's going to wait the entire 2 seconds before it sends any markup back to the browser. All right, so before you get any response back from the browser, or back to the browser, from the server to the browser, it's going to wait that entire 2 seconds and then start to send bits back to the browser, to the client. Where you start to see the evolution of web development and streaming and performance is you start to look at this and you say, hey, that H1, that header, that is a static piece of text. That's not dependent upon anything from a database. It's not depending on loading any data. So what if we had this magical world where we could send the header back and then just wait for the rest of the stuff and stream that when it's ready? Welcome to streaming. So how do we enable this? And I'll kind of scroll through this just so you can kind of see where I am inside of the README file as well. So we're talking about adding streaming with React Suspense. So what we want to do is not await this promise. We want this to actually be a promise. We are now going to pass, or not mark this function as async. We're going to go to our product list component. We will update our products to be a promise that will eventually resolve to an array of products. We will come back, and we will wrap this in Suspense. We'll get auto import from React. We'll add a fallback here in a second. So we're going to wrap this product list component in Suspense. We will set the fallback. The fallback is basically going to be, what do we want to show in the browser while that data is being loaded on the server, finished loading on the server, before it streams back to the browser. So in this case, we can have a simple div. You may, if you've kind of seen the idea of streaming before, you may have seen this, but we can have a simple div with a piece of text that says loading, And that should look okay. And the last thing we need to do is actually move over to our product list component. We can mark this function as async. And now we can add, hey, I'll get some autocomplete in my editor. Now we can await products within the component itself. So we can save this, and we'll do a refresh. And I will, again, point out the very small loading indicator. Sorry about that. But what you will see is that we do have the H1 comes through, and then we have that loading text. And just we can dramatize this to say this is going to be 10,000 milliseconds, so we can really see. So we immediately got back markup that includes our H1. That's a static piece of markup. It doesn't need anything from a database. We immediately get back the loading indicator that shows to the user something is happening, and then that connection is staying open to where after that data is finished loading on the server, it's now streamed to the browser. So we have a really neat way to handle these scenarios where how many people have worked in like just regular React before, and to do an API call without doing stuff on the server, you have, your data is null, your error is null, your loading state is null or false or whatever, and then you have a use effect, you make a call, you keep track of all these things and blah, blah, blah. This is really kind of the future, I think, of across ecosystems, but especially obviously in the Next.js world of how we handle that in a simplified way. So that's really cool. What I want to introduce next, or maybe just emphasize again, let's summarize that. What we have is the ability to have static markup. We have the ability to define individual components that are async, that async when wrapped with suspense now triggers the ability to send back the markup that's static, stream in data as it's ready. Fun fact, that doesn't happen if you don't wrap it in suspense. So that will be kind of what we had before, where we're just loading, we're waiting on the server for that to finish. And the next evolution of this is PPR. So I don't know, it's probably too broad of a question for me to ask, hey, is there anything that we noticed that could be improved with what we're doing? So I'll kind of guide us down this conversation and introduce the idea of PPR. So with data streaming, and we talked about the static markup that gets sent back to the browser first, what we're doing is still making a request back to the origin server. So when you deploy an application on any hosting platform in the world, what's the first region you see? Or a region that you see? US East 1, something in New York City. You also have like data centers in Tokyo and Seattle and wherever. You have usually one particular place that you're deploying this entire application. So in this case, if we have an application that's deployed in New York, what this means is if I'm in New York City, great, I make a request to the server is pretty close to where I am. That process that we just showed is going to work pretty quickly. If we're all the way on the other side of the world in Japan, what we're doing is still making that request all the way across the globe. Speed of light is an actual challenge in modern applications. We're still making that request all the way across the world, which means speed of light is a factor. And so we're still dependent upon the distance from me to server of how fast this application is going to even be able to load that first static part. So you don't see that show up here when we're developing locally, but that actually does factor in. Now you can juxtapose this with another rendering strategy, which is fully static content that is replicated on a CDN across the world. CDN, Content Delivery Network. Platforms, deployment platforms have data centers all across the world, 10s, 20s, maybe 100. I'm not really sure on like total numbers, but lots more than our single instance of our application. And so what if we could have those static parts actually be statically built, cached, and live on a CDN and replicated across the world? How would that change the experience for what we just talked about? Well, if we're in New York and our application is deployed in New York, we may not see much of a difference. Probably whatever the closest CDN node is probably relatively close to us, just as the data center is that we would be making a request to the server to. But in the case where we're in Japan and we're now making a request to the local or the closest nearby node for a CDN, that initial static part is going to be a lot faster. And that's really the whole point with streaming, and that's how and why we did that first step, was we want to get something to the browser as soon as possible. We give them loading indicator, and then we fill in the gaps after. That's essentially what PPR is. PPR allows you to take the static parts, and you can think of it in this case, the things that are not using await and suspense. All the rest of it that is static now is a file that goes and lives on a CDN. Anytime someone makes a request to your website, they're going to get the closest one to them. They get that thing, and then the part I can't explain, and that's why Vercel is here, is the infrastructure logic that then marries up this cache CDN file with being able to connect that to streaming stuff from the actual server. If anybody wants to go like ask details about the magic behind the scenes after, I'd happily go with you and have that conversation. That's also one of the beautiful things. Somebody asked a question earlier about abstractions. At what point do we kind of sacrifice control for abstractions? This is an abstraction that I'm pretty cool with. Like, I'm interested in how it works, but I'm very happy with what the result and the developer experience to get there is. So from a partial pre-rendering perspective, really what that looks like in Next.js, and this won't really impact what we're doing locally, but this is experimental right now. So if you want to enable this in your Next.js project, you can update, including the experimental flag in your next config, and then you can mark a property inside of your routes to say, hey, I want to use PPR on this particular route. Vercel takes care of the rest. I'm excited to see, I don't have any insider knowledge, I'm excited to see that become stable at some point, I would assume in the near future. But for now, there's a couple of different configuration things to happen to enable that. Now, PPR aside, talking about PPR, going forward, everything that we're talking about, PPR is already supported. By doing these things, we don't have to do anything else. So we're going to continue to iterate on what we've already started to build so far and think about the developer experience for someone that's authoring components within this library and the developer experience of someone who's consuming and using those components in their code as well. So one thing that we can do is let's go back and have this be a more reasonable time. If we look at this, loading ... obviously not super impressive. So let's first start by making that look a little nicer. Inside of our fallback, again, we can define this to be any React element that we want to. In this case, we've already included inside of the product list component, we have a product, oh gosh, when it's zoomed in, it takes up the entire screen. Product list skeleton component. Skeleton. It takes a count property, but the count property by default works pretty well. I will get some IntelliSense in my editor. Go ahead and import that up here. And we will save, refresh, and you'll see we have a much better looking experience now. So we actually have a mock-up of what those cards are going to look like. It shows that loading state, and again, we get the streamed in version. The really cool thing about this from a layout shift perspective, and you've probably seen this, even if someone does do a loading indicator of some sort, they may not really match exactly with what the height will be of the content. So at least in this case, you can see exact mock-ups of those cards and their details to have a pretty good experience from a loading perspective and make sure the user understands what's happening. Now, we're going to kind of go down this journey of things that we discussed when we were building this and considerations that we had. So one of the things that's really interesting, and probably the hardest thing to understand in Next.js specifically, is where your code runs. Does it run on the server? Does it run in the client? And you may or may not have paid attention to or experienced this, but there's also the combination of those things where it runs both first on the server and then on the client. And so when we think about building a relatively abstract component for this library that we're building, we don't know if they're going to consume that component in a client component or a server component. So how do we support both use cases? Because what we'll see is if we were to mark the page component as use client and refresh our page, we're going to get an error eventually. There it is. Next.js is going to come up and give us details. Product list is an async client component. Only server components can be async at the moment. This often is caused by accidentally using use client to a module that was originally written for the server, right? So the point here is we don't know exactly how the consumer of this is going to use it. we can have an idea, or we could explicitly say you can only use it in this use case. But what if we wanted to give the flexibility to the consumer of this component to choose how and when they use it between client and server components? So to support this, we can use, no pun intended, the new use function, relatively new in React. How many people have seen or use? A couple hands. Cool. So we can think of this in a lot of ways as a replacement for await. So that gave an auto import at the top, by the way, and I will wrap products, and then we will make sure to mark this as an async function, which, take away the async function declaration, because that can only be used in a server component. And now this looks okay. So a couple things to know about use. It is not a React hook. And if you actually look in the React documentation, it's not listed under the hooks dropdown. I think just generically they call it a function. And the second thing is that it integrates with Suspense. So if you think about how we wrap this component with that Suspense component here, there has to be something in the component that it's wrapping that like triggers the Suspense component itself. It was the use of await a second ago. Now it's the use of use. So we can save this, we can refresh. Hopefully we'll see. We have no errors. So now, yay, we're able to support both client and server component uses of the component that we are creating to be generically used either way. Now, another consideration, that we had is right now we are expecting the product's property, to be a promise. This probably makes sense for most use cases, but what if they don't need to load? What if the consumer doesn't want to pass a promise? What if there is just a static list of products and they don't need to do a network request or a database call? What if they just have a static list of data that they want to be able to pass down to a product list component? Or what if it exists in the client component at the top level, that data has already been loaded, and now I want to pass it down to product list component? I don't want that thing to be awaiting a promise if I don't need it to be. So how do we support that use case of generically allowing them to pass either the data or a promise that resolves to the data? So we can update our products definition inside of our interface. So we can say products can either be a promise of products data or the product data itself. Then we can scroll down, and now we have a problem that use is only to be used with a promise. So we can get, not necessarily hacky, but we can do a check to say if products instance of promise, I think that's a capital P. Hey, look at all this IntelliSense from my editor. If it is an instance of a promise, use used. If not, just take the data itself. Well, this should still work exactly like it worked before, passing a promise. You saw the loading state was there again for 2 seconds. We can prove that this works by going back and just passing in that static data now. So instead of the promise, we're going to pass the data itself. And if we refresh, you probably won't even realize that it refreshed. You can see a little jiggle in the images to show that that's refreshing. But now we're able to support 2 more use cases, or maybe 1 more use case, which has 2 options, being able to pass synchronous and asynchronous data and be able to handle those appropriately. Cool. Doing that instance of check, or actually, writing the logic for the interface definition to if we go back over here, from a creator of a component within the framework that we're creating, this is a little annoying, having to do that all the time. It's not a big deal, but it's a little annoying. So we can add a little bit of syntactic sugar to make that a little bit easier. And we can add a type called streamable, and we can say streamable type T, generic properties. People have seen those before. Basically, when I use this, I get to tell you what type of data it is. And streamable just says what we did before. Either it's data or it's a promise of data. And we can update our interface definition, going all the way back up at the top, to match that. So instead of promise, we can say this is streamable, and then we can get rid of the or product array. Functionality is still the same. It's just a little bit easier if I'm authoring a component for this library. And now the thing that is actually kind of inconvenient is from a developer experience perspective, from a consumer perspective, and I'm going to go back to add my promise in here. I don't really want the consumer to have to manually wrap things in Suspense every time. I want to take care of that for them so they don't have to worry about it. Okay. Well, what does that look like? We can go, sorry for the fast scrolls, come into the bottom and we can add in, I might have missed this snippet somewhere. Not that one, not that one. I'll just copy it. This is why we have backups. So I want to get this component, which is a product list wrapper. We're going to need to import Suspense from React. That component looks good. This just does all the stuff we just did. This means now that I need to, instead of referencing the product list component, I need to reference the product list wrapper component. We will pass in the products. We'll also have, what was the property color scheme? Is dark. Did I pass in all those properties? And then we'll get an import here as well. So these are just unused errors. We'll come back to that in a second. So we'll save this. We'll go back and refresh, and we should still see same functionality. So this is a little cleaner for a consumer to not have to worry about handling that themselves. Inside of the component, inside of the library, inside of the components, they include their own UI skeletons. These are copy and paste components, so you can customize those as much as you want to. But one of the things that's a little odd is it's maybe a little picky, but we name this product list wrapper. I don't love it. So maybe we can, instead of creating a separate component, maybe we can build something that is more generically built into the UI library that we're creating to handle this scenario and not expose odd names like product list wrapper, or require, you can name this however you want. You could expose product list, you could have a component inside that's called product inner. I've seen that pattern before. Use product inner, wrap it in Suspense, blah, blah, blah. So how can we make this a little cleaner? And we're gonna go through just kind of copying and pasting a couple of snippets in here, and we'll talk through what they are. And I'll start with this one. So first I'm gonna get rid of product list wrapper. We're gonna kind of build this into what we're doing. So we saw earlier that we had this check for checking to see if something was a promise. We also then conditionally use used or not if it was. We create a couple helpers just to make that easier so we're not having to rewrite that code. We can reuse these functions, utility functions in other places as we build out more components. Now if we scroll down, we've got a little bit more we can copy in here. And again, we'll take a look at this together. First of all, we expose a stream component. Stream takes a value, a fallback, and children. Value, first of all, fallback matches what you expect in Suspense. Here's the thing that we want to display while things are being loaded. Value now is the streamable data. Remember, streamable is an abstraction across promise of data or data. Then we also have children, which is a function, and we're basically implementing render props. People remember render props? It's been a little bit. And so what we do is we wrap Suspense around something called useStreamable. So fun fact, if we were to write the code right inside of here that handles the logic, so what will become calling the children function, if we were to do that directly in here without this being a separate component, Suspense will not work. So we separate that into its own component called useStreamable. That thing takes in value in streamable. It is using useStreamable up here, the thing that checks, is it a promise? Use. If not, take the data. Basically, that data is going to resolve, and then it's going to call the children function using render props to pass those properties to the children function. The children function will then be responsible for rendering what happens after the data is loaded. All right, this is probably the trickiest piece of live coding I will do. So somebody send a prayer up to the demo gods. We're going to return. See, already off to a bad start. We're going to return something, and let's go ahead and wrap this entire thing. When I was practicing, that's the first part I forgot. And then inside of here, we're going to use stream. That stream component that we just created, we're going to pass our value, which is products. We're going to include the fallback, which is again our product list skeleton. Now remember, the skeleton is internal to the component that we're currently working in. Eek. This makes me nervous. I don't know if y'all get nervous, but I do. And then we'll close out, see, I'm already fallback, that, yep. And then I can get rid of this. Let's wrap this whole thing in the stream component, go all the way down to, yes. I'll fix formatting in a second. Now remember, this is using render props, which means that inside of this is a function that takes in a property. In this case, this is products, and then is going to return something. And hopefully we can cheat and get the formatting to work here, where we just remove this. Obviously, I was going to mess up this functionality, which is why, because I knew that part was tricky, and because I don't trust myself live, and because it might be difficult for you too, I'm going to cheat and paste the finished example. It'll look something like what I attempted to do. All right, so if we scroll back up to the top, did I not delete the original one? Part of the skeleton. Oh, did I move this to the... Yep, that's why we don't live code. Thank you. Working in the wrong spot. So let's just, I don't know if you're a big fan of Command Z like I am, but let me get back to a working state before I started messing things up. Hopefully, if you're following along, this went smoother for you. And let's go back up to the real component that we want to create. I thought something in there didn't look right. This is the one, and I bet had I been on the right spot, I could have actually done it correctly, but here we are. Now we paste it in, no errors. Yeah, you can clap for that. I would appreciate it. Thank you. I don't know if you understand the anxiety that comes with live coding and having something not go the way that you expect it to. So what this comes down to is now, instead of using the wrapper, we're just going to go back to using product lists. We can get rid of the reference to product wrapper. We can get rid of the product skeleton. We can get rid of suspense. And now this is pretty close to what we want the developer experience to be for someone who is using these components and wants to have all these features and functionality built in. One thing we're not talking about is error states. So the same way we're handling loading states, you do the same thing for error handling and showing those. Like again, go back to the regular React and you're tracking, do you have data, is it loading, and do you have an error, right? Like all those things are kind of the similar process here. So let's save this, fingers crossed. Feel free to clap if this works as well. Hey, it works, yes. I would say as a consumer, that's a pretty good developer experience. I'm pretty proud of that. The interesting thing though, is we can kind of trigger this thing if we start to experiment something slightly different. So let's go back to the page. Let's make sure this is use client. And let's just say we want to scroll down and we want to get fancy and we want to shorten this code. We can use on a promise like so, promise.resolve. What promise.resolve will do was take your data and basically convert it to a promise. So if it's already a promise, it still is a promise. If it wasn't a promise, now, hey, it's a promise. And hey, TypeScript is happy, IntelliSense or highlighting is happy. Like things look good, I can use this with use. Cool, hey, that looks cleaner. That's a reasonable thing to do, right? Well, we will trigger another error that doesn't show up. Do I use streamable? I know what it is. This is why we rehearse a lot. that worked as it was supposed to, yay. But if we were to pass in default products, which is in fact not a promise, it's just an array. Now, hey, you can also clap again, thank you. We're triggering some sort of issue, and basically what this is saying is, remember that the data that we're passing in is not a promise, so we're now creating a promise on each render, but then use is like waiting for that thing to resolve, and when that resolves, it re-renders, and when it re-renders, it creates a promise, and then it waits for that promise, and then it finishes, and then it re-renders, and so basically you're getting into an infinite loop of creating promises for that data on each re-render, because each time it finishes resolving the promise, now it's recreating that new promise. So there's an interesting solution to this. They actually talk about this. It's an uncached promise, which basically says like, hey, we've seen this promise before, but we don't know it. So we're just recreating it and referencing it the entire time. So in the last couple of minutes, we'll copy in a couple more snippets. We've got 2 here. Basically what we want to do is create a cache for those promises. And so I'll paste in this one, and then I'll paste in this one. And actually I'm gonna cheat a little bit more, but let's look at this really quickly. Promise cache is a map. It's a map with a key of a string, value being an object, a promise of unknown in this case. And I think this was not the one that I was trying to get in. Or was that? I guess that was. So let me actually, just to make sure on this as well, I'm just gonna copy and paste this whole thing because there's a few different things that we need to change. We need to update our component to accept a query key basically that can be associated with the cache. So we can save this. We should get an error on our product list now that says we're looking for a query key, and we can just say product list. And now we will leave this with default products. We should see that error goes away because after it's seen that promise, it saves it in the cache. Next time it sees that promise, it gets it out of the cache, so no more re-rendering. It's the same thing. So that will still work. And then if we go back to passing async data, now that is going to work as well. So there's several different, were you going to start clapping without me prompting? Thank you. I'm not above prompting for clapping, but I will absolutely take it if I don't have to prompt. So, big takeaways. We are building something with developer experience in mind. Well, two developer experiences. We're building with developer experience of someone who's creating components for this thing. We're also thinking about the developer experience of the consumer of these components as they use this. And this comes from what has become, for us, Vibes. So vibes.site, if you're interested in checking this out. There's links in the README, so you can get to it there. Inside the docs, you can see there's a specific product list somewhere in the sections down here. There's a product list component. This is exactly what you just saw. And just to finally wrap this up in the last, God, what good timing I have, 1:45, is you'll probably notice that all of these utility things that we added, they have nothing to do with product list component. They have everything to do with how we abstract away streaming and loading and blah, 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 but they don't have anything specific to do with this component. So if you look in the source code, you can actually see the final example of that, which is a streamable file. You'll see a lot of familiar code in here. A lot of what we did is copy and paste. The caching in here is actually much more intense. I didn't think it made sense to go through it here. I did a simpler version of our cache. This also handles promise.all. So we just looked at what if you pass one promise, but if you're doing products, you might have products, you might have compare products, you might have other data that is associated with products that you want to stream in as well. So that gets really complicated. So how do you handle caching when you're doing multiple things and promise.all and make sure the right data gets to the right spot? So the caching in here is a little bit more fleshed out. But all of that is now in its own file that we can use in our own components as we build through. If you look at all the components, any of them that take async data now use the stream component. Our goal is to actually turn this into eventually an NPM package that anybody can use at any time and has all these things baked in. And I think that's a pretty cool thing, honestly. So the last thing I'll say is this is the base UI library that we have included at BigCommerce in our reference architecture called Catalyst. Catalyst is a Next.js application. It has all the best practices of Next.js and PPR and streaming and loading states and error boundaries and all these things built in. It integrates with MakeSwift, which is a visual website builder, and it uses a lot of the stuff that you saw here. So hopefully they gave you a good idea of kind of the journey that we went through, some of the learnings that we had. If you're interested in talking more in the next 30 minutes and or at the happy hour, we're the BigCommerce team, so we have a booth right around the corner, and we'll be at the happy hour just hanging out. So thank you all for being here. Really appreciate it. I hope you have an amazing rest of the day.